Okay. Hey, everyone. Thank you all for joining us. Welcome. This is the AI 103 panel. The subject of this panel is artificial intelligence can't exist without the right humans to implement it. This session takes a deep dive into the how-to aspects of implementing AI and machine learning, how leaders choose, evaluate, onboard, and empower data scientists, and what other team roles and skills are mission critical. My name is Brandon Purcell. I see some familiar faces from yesterday in here. I'm an analyst at Forrester Research. I cover advanced customer analytics and artificial intelligence. I'd like to introduce my panelists now. Maybe we could start over here and go this way.
Sure. My name is Andy Barkett, and I am currently the VP of AI Systems and Machine Learning at Rex Real Estate Exchange. The way I got there is that I was a software engineer, and then I worked at Google and Facebook, and then I had the weirdest job in the world, which is I was the CTO of the Republican Party, which is even weirder than it sounds. And that was in the 13-14 cycle, so don't blame me. Anyway, I ended up now at Rex, which is a startup that's disrupting the real estate industry. So.
Hi, does this sound okay? All right. My name is Ahmad Abdulkader. I'm the CTO of WorkFit. We are building an enterprise voice assistant for Alexa for the workplace, if you will. Before that, I'm a machine learning guy. I worked at Microsoft. I worked at Google. I worked at Facebook. I'm an old guy. I worked on various machine learning problems, from web search to handwriting recognition to online advertising, speech recognition. Right now, as I said, we're mainly doing NLP, speech recognition, for the purpose of making people more efficient in meetings. So nice to meet you all. Looking forward to the talk.
Thanks.
My name is Jake Klamka. I'm the founder and CEO of Insight Data Science. So Insight takes PhDs, as well as some engineers now as well, and turns them into data scientists, essentially. So my background was in particle physics. I was doing machine learning, large-scale data analysis on the Large Hadron Collider. Very similar tools and techniques, but very different contexts than the sort of product business world. And started Insight to basically help other folks like me who are essentially years of experience in the research academia space in various fields like physics, neuroscience, math, biology, and help them kind of translate those skills into industry. We now have about over 1,000 alumni of Insight who are working as data scientists and data engineers across the U.S. So that's my background. Yeah.
My name's Andrew Busey. I'm the founder and head of product at Conversable. So we make conversational intelligence systems. So lots of AI and ML stuff integrated in that. And I've been sort of working in chat messaging, commerce, and games for the last 20 years making products. So started making the first chat-based automatic call distribution systems a long time ago and been building startups since then.
Great. I mean, one of the things we're going to be talking about today is the scarcity of talent, of people who have experience building artificially intelligent systems. We're fortunate enough to have 4 of them on the stage today, so that's pretty cool. Let's address that scarcity first. I mean, for the last 8 to 10 years, we've talked about the dearth of data scientists. Is that impacting the ability of companies to implement artificial intelligence, or is data scientist even the right word? What's the role that people should be looking for? What are the skill sets of that role? And most importantly, how on earth do you find these people?
I actually want to sort of distinguish two. They may seem like they're the same from afar, but they're not. Data science and actually machine learning. And I look at data science as the attempt or the discipline of trying to find structure in data. And once that structure is found, it's then actionable by humans. Humans can take action, whether they're marketeers, business people, application engineers. But it is the goal. This is the goal is to actually find that structure in data. And in the process, statistics is being used. Actually, machine learning can be used to find that structure. But it's important to find that insight and understand it in a human comprehensible way. AI is different. AI's goal is to actually do prediction. Whether in the process I understand what's going on or not is irrelevant. And we see that with the representation learning. Representation learning totally annihilated this idea that things have to be human comprehensible at all, right? All I need is to predict the future, predict the performance of an unknown user, understand maybe what happened in the past, but finding structure in data is a, something, maybe a side goal. I may do very well, but not understand actually what's going on. And I think the requirements for individuals who work in each of the disciplines are fairly different. Like data scientists and maybe AI scientists, engineers. And there is scarcity in actually both. Although it's much more acute actually on the AI machine learning side than it is on data science. And we've shown perhaps that it may be possible to lower the barrier to entry for people through the data science to enter into the data science discipline. It's much harder. There's a lot of math that's involved, for example, in AI than what's required, at least from what I've seen in data science. So I think it's important to actually have the distinction for if you're a company and you're trying to hire, which one do you actually need? Because this will affect the requirements that you put out there. This will also affect your expectation of what kind of people you're going to get. And if you're willing or prepared to actually do some training and help people become a data scientist or become an AI engineer, to have a good expectation of what's required to actually do that.
Yeah, I mean, one more perspective to add is that I would say in the beginning, there were computer scientists. And what I mean by that is that almost everyone who populated an AI group early on, or even a lot of the people who went into data science, came from the software engineering world. That was true at the beginning. It may not be true in the future. Now there is a pipeline that goes directly from college through certain programs to data science, from college through certain kinds of things to deep learning, whatever it might be. So I think that when you look at the resumes of people who are in the roles now, it may not provide the right blueprint necessarily for the future. Although I will still say that on the AI side, in the engineering side, that is still a heavily computer science dominated field. Not quite the same as data science. There are a lot of people who are very smart statisticians, don't write a whole lot of code, or maybe don't have the same software engineering skills, but work as a data scientist.
Great, thanks. Jake, it sounds like you helped to create applied data scientists. So how do you do that?
Yeah, we definitely see these two divisions as well. Although it's interesting, before kind of the recent AI kind of hype with that keyword being used, data scientists often were either kind of data scientists, what we call them product analytics, I think, or some data scientists would be called data science, machine learning, but then there'd be a big overlap with machine learning engineers, to your points, and so there's real big overlaps here in these two areas, and we've certainly approached it more from the data science side, but also have, I'd say about half of our fellows work on machine learning and half end up going work on the sort of product analytics roles. For us, what it was is, for me, it was tapping into the academic networks and realizing that, it's not just the computer scientists who are doing a lot of really sophisticated work in machine learning, as well as modeling, and realizing that those folks actually have years of experience already doing some of this work. And so, example for us was, we have this data science program we've been running for about 5 years, and just most recently starting an AI program purely focused on machine learning. And we had someone come in from an astrophysics background who is doing very sophisticated, cutting-edge deep learning on astrophysical data for the last 2 or 3 years at NYU, for instance. It doesn't say NYU computer science, machine learning group on that resume. It says a bunch of astrophysics terms that probably most of us here wouldn't recognize. But at the end of the day, he was doing deep learning for years and is a really world-class expert in it. So all he needed to do was come in for a few weeks, do a project in a different context where instead of trying to pick out, black holes colliding or whatever in dark matter data, but he's actually doing focus on user sort of prediction, and that transfer can be made quite quickly. It's still a very, very rare skill, but these folks are in various places, and we're finding them. So, yeah.
I think we take a little bit of a different approach because I'm in Austin instead of the Valley, so we don't have quite the access to machine learning and deep learning talent of the same pedigree that you would see here. Not a whole lot of Facebook and Google AI and machine learning labs. So what we've gotten pretty adept at is retraining people, and I think what I see today, having sort of been through these drills many times, I do think that AI and machine learning is different than a lot of what's happened in the past, but I do think a lot of it's also the same. Like, I took a little foray into gaming about 8 or 9 years ago, and at the time, Flash developers were like the hardest unicorns on the planet to find. They were super expensive. People were like panicked. There were like 4 billion like trained Flash engineers things. Now no one actually cares about Flash engineers. I don't think machine learning is going to go that path, but I do think that basically a really good computer scientist who understands some basic math can learn a lot of machine learning. They're not going to maybe be a rock star in Facebook's AI lab or Google's AI lab, but they can build pragmatic applications for startups like us or big companies that aren't going to go build primary research labs. And so I think we're going to start to see a little bit more stratification between hardcore kind of research-oriented AI and machine learning people, both on the data science and the engineering side, and more pragmatic implementation-oriented people, especially as libraries like TensorFlow and Keras become more and more stable and powerful and allow a sort of access to the underlying technology to a much broader audience.
Great, thank you. Yeah, you know, a lot of the data scientists I talk to have been using what I would say are traditional machine learning methods for a long time: regression, classification, clustering. Most of these are transparent, meaning that you can look under the hood of the result and see how the model's making its decisions. But I think a lot of the hype around AI today is driven by neural networks and deep learning. And that requires a different skill set, right? Because those are opaque algorithms. They're very good at dealing with unstructured data, whereas for the others, you need to structure your data and prepare it. If you're not Google or Facebook or Amazon, where do you go to find somebody who's adept at training a deep neural network to recognize an image or a speech? Or do you even need to do that? Should you just be leveraging Google or AWS?
Yeah, so as I said, I'm an old guy. I belong to the previous sort of generation of folks who, you know, with the previous hype of neural nets that happened in the early 2000s. And I was very sad to have, you know, to see it sort of fade away to SVMs and, you know, graphical models and then come back. So what is sort of sad is that some of the reasons that caused neural nets sort of to disappear for a while, and you know, they still exist. One of them is the lack of sort of transparency or sort of human understanding of what goes on in the model. My view, which is actually I don't think it's shared by many. I'm a neural net practitioner, and I, you know, sort of like neural nets can beat any type of technology anytime. You know, just to challenge everybody. I hate SVMs. Anyways, so that aside. I think this is hype to a great extent, you know, this sort of, you know, comprehensibility, if you will. By insisting actually that, you know, that a particular hypothesis that a classifier makes or a regressor makes to be human comprehensible, we're eliminating a whole set of hypotheses that could be very, very useful. And I ask actually cynically, do we as humans understand how we make, you know, decisions? Can I really articulate why I think this chair is more comfortable than, you know, the chair that is sort of at the back? We struggle to do that, actually. We have limited constructs by which we can actually express sort of, by insisting that classifiers articulate this in these human constructs, I think it's sort of the wrong, you know, sort of track to take. Having said that, that doesn't mean that we can't come up with, you know, statistical techniques and tricks and tools that will give us insights about the data, for example, for debugging purposes, or make statements about the possibility that a particular feature is buggy, or that the data is worth relabeling of sorts, that there's, you know, signal-to-noise ratio is not very high. But I think this sort of quest to actually make, you know, open the box and understand what's going on is sort of in the wrong direction, you know, to take. And as representation learning showed, I'm very comfortable learning and inventing and building an algorithm that would solve the problem for me than understanding how the algorithm actually solved the problem. I think this mindset will help us a lot and will direct our resources, as scarce as they are, in the sort of the right direction. One of my friends, his name is Paul Viola, he's very famous in the computer vision world. He used to say, a neural net has to come with an expert to make it work. They require a lot. We still don't understand. That's the second reason they may sort of, you know, there may be a second decline. We don't know how to tune neural nets very well. It's not really well understood how to actually find the right parameters for a particular neural net to work. And as we're sitting today, there may be a neural net with a different set of parameters that perform way better on ImageNet. And some student somewhere, some brilliant student somewhere will run into these, and will always be, So I think one of the efforts that perhaps academia should be, pay attention to is better ways, more solid, rigorous ways to actually sort of tune or figure out the right parameters for these neural nets. Until that happens, we're compensating for that by lots and lots and lots of data. Data compensates for the lack of tuning. Yeah.
When I worked in politics, we used to discover really weird things. Like, we thought we could predict who was going to vote and who was going to vote Republican or Democrat. It turned out that, like, the best model we ever came up with was if you're a female in certain states and you wear over a size 12 dress and you go to church, you're going to vote Republican. No idea why. Now, what was interesting about that was that particular insight seemed really, really useful to people in a certain function. Because they thought, okay, now we can take that and we can go make a TV commercial, or we can get whatever we're going to do. When you build a neural network, it doesn't give you that insight that you can go take to your marketing department and they know how to use. Instead, it gives you a piece of software that you can run that does something. So I think one of the big challenges is being able to operationalize what you get out of a deep learning project. And operationalizing that today is much easier than it was in 2004. Today I can go on AWS, I can spin up something that can both do the training of the neural net and actually do some sort of useful business thing. I can set all that up like in an hour on AWS. That was not true in 2004. So I hope that while you may still need an expert to tune it, you no longer need an expert to use a lot of that neural network stuff, which means that it can do stuff differently than just creating an algorithm and handing it over to your marketing department, which I think, back to the original question, means that those black box things are more useful in today's context because they don't need a whole team of software engineers and system administrators to run them.
Any thoughts, guys?
Yeah, I'll take the we don't have PhDs and we're really pragmatic side of the world. I feel like those are all legitimate things and are important, but like most of our clients don't really have any data to start with or don't know where to get the data, so you can't really train a neural network with no data, right? I mean, it doesn't matter how good your people are, which is I think where data analytics and data science comes into play. I think it's where actual product planning and strategy comes into play, and I think that we have a lot of Fortune 500 companies, and some of them have some types of data that we could use, but getting them to actually share it with us so that we can do anything with it is very hard. So usually it's like stand up something that kind of works as quickly as possible and start collecting data that you can then use to build something better later. So even though, SVMs might not be the fanciest, greatest things on the planet, they actually are pretty useful in certain very specific use cases, and they do allow you to collect a bunch of data that you can then use to bootstrap up to a much more sophisticated neural network later. So I think part of, as you think about like how to put together teams like this, you have to also think about where you're going to get the data from. So if you're a startup and you have sort of captive control end to end of that system, you can do a lot of really amazing stuff quickly. But if you're a big established business, you probably are going to have a lot of infighting to get that data. You're going to have, an army of lawyers that care a lot about PII issues and sharing that data or what you're allowed to do with it. And that's where, again, like, what is it actually doing with the data? And, I can't see it. So I can't, as a lawyer, I can't articulate, what's going on. So as we kind of talk to big established companies that are, less, have less of a core competency around technology and engineering, those are become really significant sort of chicken and egg type of problems.
Yeah, maybe I'll just add that a lot of teams that we're seeing out there that are doing really well are actually trying to kind of combine all these different pieces on the team. So to your point, the infrastructure is phenomenal now. We have fellows that like implement applied deep learning stuff and get it set up like you said in a day. It's incredible. But you still sort of, when you're doing things in production, you need that sophistication. And so a lot of teams will make sure to get one person who often is called a data engineer, so that they're kind of, that's their cup of tea, is that infrastructure piece. Then they'll get someone who often they'll call a data scientist, is more in this category of sort of hey, let's just do the simplest thing possible. Simple, I mean, it's still sophisticated machine learning, but let's not go all the way to deep learning, whatever, but let's just start getting early results. Whether interpretable or not depends on, I guess, the application, whether it's needed. Let's get that buy-in from the organization, so maybe there's a product-minded person on that team too who's doing a little bit of that work. And then if there's a sense that some of these more sophisticated deep learning algorithms and neural nets could be helpful, they kind of bring someone onto the team with that background to then sort of further optimize and go up the stack, and especially once the data builds up. Now, obviously, I'm kind of oversimplifying this, and each team is different, but having those three different sort of roles to some extent and acknowledging that they exist, and then thinking about when I need to bring each one of those like roles into the team has been super helpful for a lot of teams that I've seen. Versus teams that just say like I need all in one of these categories and not really kind of realizing that mix is helpful.
Yeah. Thanks very much. Andrew, you brought up a really good point. I mean, when I talk to our clients at Forrester, their top challenges are ensuring data quality from multiple sources and accessing data from those sources. So I know we're talking a bit futuristically, but a lot of companies just struggle to get data or integrate the data that they have. In the absence of the ability to do that, like what are some workarounds companies can do to be able to start taking advantage of machine learning when they're really struggling to even understand and integrate their data?
Today, I think what's emerging is a sort of a marketplace for sort of models and ideas that's out there. So I've seen many instances where the first instinct of an engineer, or machine learning, or data scientist, or even a product analyst, is to actually go on the model zoo for TensorFlow and find a model that actually was built by some public data of sorts or proprietary data, and download it and use it for their purpose, and that presumably would get them to like 70 to 80%. So I look at that as a marketplace that's emerging for that. Kaggle is another instance of that, where people, companies put their problems out there, and people, publish whatever data they have, and allow people to use sort of, worldwide resources for their, to build a model that would satisfy, or optimize a particular metric. So I see actually a marketplace emerging where people or companies, departments, and in bigger companies would reach out to sort of talent out there, and they don't necessarily have to staff a machine learning group. It's very expensive. Sometimes it's not justified, but they can reach out to consultants or contractors out there and ask them to build a model that would do So that's, of course, this is a pretty expensive proposition. But at times when data is dire and it's very hard to hire, that's one one way of doing things. I think things are also eventually we may not see that right now, but some of the standard components, machine learning components that people use will be commoditized. In the next 3, 4, maybe 5 years, that people will it's fairly easy to find a logistic regression model that does lookalikes, or does a collaborative filtering, Amazon style. I think these things will be commoditized, and there will be the marginal improvements that people would get would be smaller and smaller.
Yeah, I think some of that commoditization, maybe at a smaller scale, more localized scale, is going to happen much faster. I'm actually legitimately surprised that there's not a prediction button in Excel right now, because for like a lot of real-world use cases, that would actually be super valuable and helpful. And a lot of people who are sort of not maybe labeled with the giantly expensive and high-profile data scientist tag, but who have MBAs or a lot of experience doing really crazy things in Excel that a lot of people would also find amazing and terrifying, could probably do a lot of pretty interesting machine learning types of stuff if there were the right tools and plugins that go beyond kind of the traditional solverish type of things that exist in Excel now. I think that will be one path. I think we'll see probably a rise of tools over the next couple of years, because it's a huge opportunity to put the sort of shiny user interface on the desktop and activate whoever's cloud infrastructure at Google or AWS or Azure to train models and run more complicated models. So I think that'll sort of open this up to a much broader group of people, like smart MBAs who know Excel really well.
Yeah, I mean, there's this sort of Gordian knot that I think a lot of companies find themselves in. It's like, well, I could hire a machine learning person, but somebody told me I don't have enough data to do anything with it yet. I could go find a model, but I'm not really sure how to use it, you know, and they really don't know how to get started. So if you're me and you come from a computer science software development background, I'll tell you how I would start. I would take a software engineer and say, go log everything. And log it to AWS, and I don't care if just ignore the lawyers, we'll pretend that this data doesn't exist, and just log everything. And then that way you can kind of cut the Gordian knot and you can get started somewhere. Now, if you come from a marketing group, you may start in a different place and say, well, what will they let me have access to? Maybe they'll let me have all our customer support emails. Maybe that's the one thing I can get. If you can get all the customer support emails, you can do a recurrent neural network that figures out how to auto-generate responses to customer support questions or something. So I think every situation is going to be a little different, but everybody has to sort of accept that there's this problem. There's no easy starting point. You've got to just go take I guess in the mythological case it was a sword, go take the sword, cut the thing, and pick a spot. And that spot has to have one kind of data and one person who can do something with it. And that one person may literally be an intern who took a machine learning class. I think that's actually how a lot of companies get started with something.
Great. So now let's think about the executive layer for this. So Andrew Ng, Cloudera, Google, Baidu, suggests that companies need to hire a chief AI officer. Do you agree? Is there a need for a chief AI officer, or what sort of executive should own this responsibility?
I think if machine learning is a core, in WorkFit we think of ourselves as an AI company. AI is a core, competency, if you will, right, for us. It is. I feel very strongly about hiring such a person who would oversee. Not sure about the title. I think we can debate it, whether it actually reflects what this person she or he would do. But I feel strongly about actually having a person who oversees that and have a policy, and philosophy, certain philosophy on how, such a company would do that. But I think it's very important to know or decide whether really machine learning is a core, is a core competence that the company should have or not, or that the company is happy to use after all, we all use compilers day in and day out, but we don't have somebody who oversees compilers. It became a commodity, became something standard. I don't think machine learning has, sort of reached that, but there are companies who could use could use the state of the art, could use the best stuff out there. And I think only companies that, sort of push the envelope on AI or use it in such a way that it's a core component in their products or core components in the platform, I strongly feel that a person, an executive level officer should have, could be the CTO for efficiency at the very beginning, but I can very well see this, sort of diverging from the traditional CTO role. There are questions about, maybe I'll leave to my colleagues to answer, about the qualifications of such a person. How much industry experience versus depth of knowledge, academic knowledge, about machine learning. Do they need, I've been mostly on IC in my career. I've worked with really great managers who manage technology, and they know next to nothing about the basics of machine learning. So it's one thing to manage technology and, being a technologist. Of course, there are really good technologists who happen to be good managers too, or good sort of, visionaries in this space. So he or she doesn't necessarily need to be, really deep, but there are folks who know how to sort of manage technology and draft policies for companies and vision for using and employing such technology.
I'll give like the pop business book answer, which is if you're in a company where you're going to have an innovator's dilemma problem using AI, I think you need that officer. And what I mean by that is if people in your company are going to resist this because the marketing department says, no, we already have a group that does research and analysis and we don't understand why we need this other thing. In that scenario, I think that you're in a big company, Fortune 500 company, you have a lot of people who feel threatened by this who don't understand it. I can see why you need an executive sort of sponsor. In most companies, you need a person who knows how to do it. If I was at a company and I could hire this guy to do it, I really don't care what his title is. I just can hire him and then he can do it. And I think if you don't have the innovator's dilemma problem, I don't see why it matters what you call it.
I won't speak to the title of the executive part because I think you both touched on it perfectly. Maybe one thing I will say, since this kind of touches briefly on, sort of overlaps with organizational structure as well, I think wherever you put data or machine learning, put it close to product, make sure either it's in the product org or if it's in the engineering org or in the separate org, make sure it's talking to the product people as much as possible. Sometimes I think companies conflate it somehow with it's complicated engineering stuff, so let's put it with the infrastructure. And the thing is, the infrastructure stuff is often just needs to service the engineers so that the engineers are able to build quickly. AI machine learning is not like that for almost all companies. Most companies, ones on the stage included, this is like the core product. It's core user experience. And so if that group or that person or that group of people is not constantly just laser focused on what are we trying to achieve in terms of the user experience or the product outcome here, and just treating it more like an engineering exercise, there's going to be all sorts of problems. So conversely, when those two things are aligned nicely, it works very, very well because you're always focused on that, why are we even doing this? Which then gives you that sort of sword thing of okay, well, we're not going to try to do all of the machine learning, which whatever the heck that means, right? We're gonna accomplish this goal. And so I've seen that work very well for companies of all sizes.
So I think that there's a lot of people in these organizations that have responsibility for different parts of this stuff. Chief digital officers are a relatively new thing, but this may fall in the purview of many chief digital officers in a lot of ways. I actually think the person that is in charge of this probably doesn't really need to be a super expert on AI or machine learning. Actually, it's probably more important they be an expert on the data of their particular organization and what flows through their business and how value could be created from that data, which is a different way of thinking than historically. What I found to be really interesting, and having, I'm also an old guy who's been doing software companies for 25-ish years, for up until, last year, I hadn't really written much code in a really long time. Hadn't really needed to think about code that much because really everything's been the same. It's okay, well, now there's a web page in front of this. Oh, now there's an iOS app in front of it or whatever. It doesn't really matter. Oh, now it's in the cloud instead of in a rack somewhere. It's all, roughly been the same. There's obviously, we moved from kind of different types of databases to, more sophisticated things. But machine learning AI, I think, is a fundamental shift in how you think about leveraging the way that your customers interact with you as a company or a brand. And so if you don't know how your customers are interacting with you, you're not storing that data, you can't use that data in a machine learning or AI application. And if you don't think about what your customers want, you're not going to deliver the right outcomes, right? So if the use case is internal, sales predictions, for example, then it doesn't really matter what the customer sees or does. But we do a lot of stuff with big brands, and it's important to not irritate your customers, and you have to sort of wade carefully into that water to not alienate people. And so I think 5 years from now, things are going to be dramatically different than they are today. And so, sometimes our challenge when we talk to potential customers is the AI hype is so significant that people kind of want this thing that's maybe years away. So it's all about kind of articulating and explaining how what's available today helps them get to that. And I think the role of this person in a lot of Fortune 500 brand non-tech companies is going to be about how can I leverage all the data flowing through my organization to deliver something better, whether it's a restaurant or a apparel company. How can I make my experience and brand and customer happier so they buy more and they stay with me? And I think that's a different skill set that's somewhere between a CDO and a CMO, but also has to have a reasonable understanding of technology. So it's and also probably has to be able to fight with legal and compliance in a lot of these companies. So it is going to be a little bit of a different role. I don't know that Chief AI Officer is the right title for that in a lot of companies, but it might be a big new portfolio component of a Chief Digital Officer or a transition from a traditional CIO into something that's more like this.
Jake, I just want to echo something you said, because yesterday we had the AI 101 panel in here, and Safia Ali, the head of user experience at StubHub, was there, and she owns a lot of the the AI implementation at StubHub. So I do think if it's going to be a core piece of your product, you really want someone with a UX background either leading it or at least completely involved. I want to ask one more question, and then I'd like to turn it over to the audience for a couple questions. This one's kind of a passion project of mine because I'm writing a report on the ethics of AI and data science at Forrester. And I don't know if you all are familiar with Microsoft Tay, but Microsoft basically built a chatbot to interact with users on Twitter, and within 24 hours it became a racist asshole. So they had to take it down. And then they just tried to launch another one, Microsoft Zoe, yesterday or the day before. Same failure, not as bad, but still pretty awful. And it just goes to show, like, AI can be like a child, right? It depends on what you use to train it with. And as you all know, humanity does not put its best foot forward on Twitter. So it's not that surprising that you're going to get that result. What can companies do to try to prevent this from happening when they're training these models?
So I'll go from the. I've lived this experience because we sell automated experiences and chatbots to big brands. So actually, we were early in our process when the Tay scenario happened, and those conversations immediately went from we want this amazing AI that can do all these things to it can never say anything that we don't absolutely know what it's going to say and why. So to your earlier point about kind of not understanding exactly what's going to happen and a sort of discreteness versus kind of a AI magicness to it, and so. Now it's kind of moved a little bit back to, well, we want it to be like smart and roughly know what it's going to do, but be more reactive, and so that that starts to sort of bridge that gap. And so I think over time, we're going to see more sophisticated deep learning neural networks that can do more powerful things, and that's going to require kind of easing into from the shallow side of the pool to the deep end for a lot of companies. And I think that's going to require, there'll probably be another title that we didn't talk about, which is, sort of some sort of AI QA analyst type of person to make sure that it doesn't go off the rails. I mean, I've seen some futurists call it like an AI trainer. I don't think that's really the way it plays out, but I think that's actually a really important path of adoption for a lot of non-tech companies, where it's like, okay, well, we're going to start with a very programmatic set of interactions to both collect data, learn what customers want, and then we're going to slowly expand that into a much broader, more AI sort of experience.
Yeah, I mean, at Rex Real Estate Exchange, we have a different version of this problem. It's not so much about it being an a-hole, it's about it saying something that would create liability for the seller of a house. So if, for example, like we put a kiosk in the house and you can ask it questions like, how old is the roof and whatever, and the kiosk answers you. And the issue there is that, like, what if it says the roof is 7 years old and it's actually 17 years old? And that, it doesn't usually make that kind of mistakes, but you can imagine ones that it would. It's pretty risky for us, potentially. So we had the same sort of thing, where at first it was like, oh my gosh, this is amazing, the thing can answer all these questions, and then it was like, oh wait, we have to pull it back and not let it answer anything. And what we ended up having to do was go through an exercise of really figuring out where are the slippery areas? Where are the safe areas? What do they mean? It was not intuitive. So we had to go through and say, okay, it turns out that if you ask this thing about the schools that are nearby or comparable homes or the roof, it can actually do a pretty good job. If you ask it, has anyone died in this house? It can actually do a pretty good job because it's factual information. It's pretty simple. If you ask it something like, was the last remodel, did the last remodel pay for itself? Did it have a positive ROI? Harder to answer that question. It's very subjective. What you mean by positive ROI, it's not quite clear. So what we did was we said, well, what we're going to end up doing with this thing is we're going to have a sort of a QA officer for it, which we did. That there was a person responsible for training it, and we said we're not going to shy away from things that are squishy or subjective. We're going to shy away from things that create legal risk. So we defined some pretty careful boundaries for us, and that meant, like, don't make promises about the price, don't make promises about, about certain kinds of aspects, don't offer an estimate of the cost of insurance because it gets risky. And so we just had to really think through the problem. And it sounds like kind of simplistic, but I don't think most companies have ever thought about, from my customer experience chatbot standpoint, what are the topics that are risky and what aren't. And I think once you do that and you think through it, you can put fences around it that are reasonable, and you can sort of solve 98% of the cases. But that's just an activity that companies will have to go through that's probably new.
Any other thoughts?
Yeah, I actually have 3 thoughts. I'll try to mention them quickly on this. Turns out data acquisition actually is the hardest, sort of part in the sort of pipeline of building a machine learning component or machine learning system. And people, very often people underestimate and sort of discount the time and effort it takes. It is actually a core skill of a machine learning engineer or data scientist or data engineer, if you will, to acquire data properly. If I don't sample the data in the problem space properly, then you can expect to see erroneous results or unexpected results in the outcome. So this is something that sort of any practitioner, any machine learning practitioner, any data sort of science practitioner would have to insist on. The data, data acquisition process is rigorous and conforms to certain sort of metrics. And that is fairly well known from the, in the community. The second thing is, turns out that almost all of the algorithms, the prevalent algorithms, the popular techniques we use today, solve a particular set of problems in machine learning. It's called IID, independently identical distribution, meaning that I have to draw samples in a certain way during inference, during runtime, exactly the same as I did during training. If I don't, then don't blame anybody but yourself. So solving non-IID problems is very hard. And academia is starting to pay attention to these kind of problems. And I think the next generation of neural nets or representation learning will do well on these kind of problems. But today, unless we sort of guarantee IID, then hell can break loose, and we can expect really weird behavior on stuff and data that I haven't seen before, right? The third thought is, I think there's room for. I don't think we have thought about the legal implications of having a machine learning model out there, front user facing. Folks in the European Union have thought about that, and I think they're starting to do a better job, than us at actually regulating. So, for example, there are laws and rules that prohibit a face recognition system, for example, from performing much worse for females than males, right? Or for certain, if your skin color is, sort of, darker or something like that. So, I'm not suggesting we do the same, whether you're a fan of this or not. But there's room for regulation. There's room for lawmakers to think about that, the implication, and providing companies with a standard that they need to conform to. And as my colleague here mentioned, about the legal risks of actually. But there has to be laws, for legal risks to exist, for companies to have the incentive of actually doing that or not. I think there's room for that. And we have to spend the time and energy to think of these things and sort of take a pass or two of regulating these things to provide companies for standards that they can conform to. Otherwise, it's a choice that companies make or not, right? There's kind of no legal consequence. There has to be legal consequence for actually doing that for companies to, resources are already scarce. Why would they do that? But if there are laws to actually that they have to conform to, they will be incented to do that.
Thanks. Any other comments on this before I turn it over? Okay. Any questions?
Hi, thanks for the panel. One of the questions is, you guys discussed about the skills that are required on the technical side, right? So you said how things are moving from software engineers to data scientists, AI engineers, and so on. But of course, in a company, to make these things work, then you also need to make sure that the things on the non-technical side are also matching that. That can be your marketeers, that can be your product managers, or it can be also people working in operations, supply chain, and so on. And what's your take on that? The skill set and things, how those non-technical functions are getting affected from? Because the reason I also ask this is I'm coming from a traditional company, which is not digital first, which is not AI first, and things like that. And then we are companies that goes through, let's say, change as a transformation as an organization. And what you see is that on the technical side, sometimes these things are easier to understand, and then that change maybe, even though it's still a struggle, it happens a bit easier. But still, on the other side, on the non-technical side, I don't want to even say that it's resisting. It's sometimes people don't even understand. It's even awareness on those things. So also, now my question is, what is your take on the non-technical side in terms of the skill sets or the profile of people that the organizations also need to hire or grow them into new roles and things like that?
I'll take a crack at it, although I think it may be what Andrew's going to say. We'll see. I think that regardless of the title, if you're in a marketing department or a finance department, you need somebody who has an eye for and thinks about what are my processes and what is the data. So if you think about it in a marketing department, you might have a CRM system, you might have customer feedback that comes in, you might have creative content in your content management system, whatever. You need to understand what is the data that I have and where is it. And that is a skill that in a large organization is quite difficult, right? So if you go into a large company, you say, where is the canonical record of which sales forecasts were used to generate this budget? Good luck finding that, right? I mean, it's hard to find any company where you'd be able to find that. So I think that in each of those departments, whatever the title is, finding people with that skill for sort of really rigorously thinking through what is the process, where is the data, where is the canonical record of something, where are all the old predictions that didn't come true stored, you know, who is the owner of this data, all that stuff. That skill is really, really important. It might be called a program manager, it might be called a business process analyst, it might be called a marketing analyst. I mean, there's a lot of different titles, but I think that skill is really, really important. Go ahead.
Well, I suspect this is going to start to get taught at business schools, for one. So I think that we'll see a lot of sort of brand management type of people that come out of school with a much deeper understanding of AI and machine learning. I think we'll see, we're going to see consultants make a ton of money from this because they're going to have the expertise first, or at least be able to claim the expertise, and there's going to be a lot of strategy engagements. I think this loops back to the earlier conversation where I think inside the organization there needs to be someone, whether it's a chief AI officer or a CDO or a CMO, who basically, the customer first mantra is good, but to really take that customer experience to the next level over the next 5 to 10 years, you better have a really good data plan, and having someone that has the power and authority to assemble that data and track it. And obviously that's going to probably be delegated to people, but you're going to probably need a central authority that treats that data like a valuable asset in the company. So just like your CFO doesn't want to make mistakes on the numbers, you don't want to wake up in 3 years and go, oh man, we lost all this data, or we didn't maintain it correctly, or we didn't do something right with it.
So I heard some clapping from one of the other rooms, so we're going to take one more question and then wrap up. And I know you had your hand up last time.
I had a question on connecting the fact that machine learning can be a black box and you don't really need to understand it with the fact that you need to impose some rules and regulations on top. How do you accomplish those two? And I'm coming from a financial services background where the stakes are very high on not declining the wrong kind of person, etc. So it really matters.
Right, that's a great question. So if I understand correctly, just repeat the question for everybody. How do we sort of reconcile these two, accepting that the machine learning component can be a black box and having to conform to certain rules? I think it's totally possible, as long as these rules can be articulated as numbers, as metrics. We engineers, we love numbers. We know how to measure, and we've gone a long way. There's a long, deep culture of actually how to do measurements properly and stuff like that, statistics and such. So I honestly don't think that we can sort of really deeply understand or insist. I mean, of course, understanding would be good, but insisting on understanding, I don't think we need to insist on understanding to conform to sort of certain benchmarks, or we tally votes, but we have no idea why people vote in a certain way. So there's multiple instances of these sort of happening. So in the absence of understanding, we better have ways to measure the utility, or the sort of the metrics, or the statistics of whatever component that we're unconform to it. Yeah.
I mean, if something is a black box, and you can test outside of that box, and you can use computational methods now, the same methods that make neural networks cheap to run, also make comprehensive brute force testing of all the inputs and outputs possible in a way that wasn't before. So you may say, well, I can't actually audit exactly what happened, but I can say that there are only 2 billion possible inputs to this, and in none of the cases does something illegal happen, right, as an output. Yeah, I mean, maybe you put some very comprehensive test around it that says, if it makes any phrases of this form, if it uses any of these words or whatever, that's just something. We don't know why it did that. We don't know whether it was reading Huck Finn and it learned a certain word, or it was emulating some racist dude in Alabama. I mean, it doesn't matter. What matters is that like it hit this prohibited boundary.
Great. Well, I'd like to thank the panelists, Andy, Ahmad, Jake, Andrew. Thank you all so much, and thank you all for joining us today. Enjoy the rest of the conference.